let's dive right into it. So, as you all know, the topic of today's webinar is optimizing your data stack with Snowflake, dbt, Hevo, and Tableau. Hi, I am Arjun. I work as a product manager at Hevo, and very excited to welcome our speaker for the day, who is Jeff Skolberg. He is a founder of Green Mountain Data Solutions, and with over 18 years of experience in data analytics and supply chain business, Jeff is an expert in optimizing data stacks using Snowflake, dbt, and Tableau. And he specializes in cost reduction, performance optimization, and data driven decision making. And get ready for some valuable insights from a true data leader. Welcome, Jeff.
Hey, thank you so much for having me. Excited to be here. Thanks everyone for joining. Looks like a fairly full house, so that's exciting to see. And looking forward to a great discussion here.
Yep. So just quickly, I'll just dive into what the agenda for the day is going to be for everyone's reference. We're going to start off with managing costs and performance for Snowflake. We're going to jump into automating data integration with Hevo. Then we'll be going into scalable data transformations with dbt, performance using Tableau, and Jeff is going to take us through a real world case study and some best practices. So just starting off the bat, Jeff. So I want to ask, like, what are certain inefficiencies you see in the modern data stack today?
Sure. So from a very high level, the most general mistakes that I see is ignoring costs and not trying to optimize at all. So time and time again, I come into clients and I can see that they haven't even really begun to their optimization journey. So that's one mistake that I really see is not optimizing. Another mistake that I see time and time again is paying too much for loading data. So we know that there is a host of vendors out there, and it it shouldn't cost, like, let's say 30 million rows shouldn't cost like thousands and thousands of dollars.
Yeah.
So that's another mistake that I see time and time again, is kind of just going with the status quo and not saying like, hey, what's the most optimal way to load this data? Just kind of like taking the easiest path.
So
Those are two things from a very high level, and we're going to get really into the details today for Snowflake and all across all the different sections of the stack.
awesome, awesome. So I heard at least the first two things talk about cost, right? So I just want to understand, are there any mistakes that happen when companies try to optimize for cost and maybe miss out on something else, or any key mistakes that they do there?
Yeah, so one one thing that I see very often is just like incorrect warehouse configuration. So warehouses that are like oversized, the timeouts aren't set correctly, too many warehouses. This is what I would call the low-hanging fruit, and the low-hanging fruit is actually really exciting because that's where you can actually save the most money. So again, once we dive into the Snowflake section, we can get really more into the details. But just as a way of introduction, um, that high level stuff that I'm seeing right there is not knowing where to begin and not optimizing your warehouses.
Awesome, awesome. So, like Jeff already mentioned, the first section we are going to dive into is optimizing Snowflake for cost and performances. So, Jeff, let's say, what would you say is a quick hack or a quick win for Snowflake cost optimizations that
Yeah,
almost all teams overlook and just miss it off the bat?
great. So the number one thing is your warehouse auto suspend. When you spin up a new warehouse in Snowflake, it comes with a default of 5-minute auto suspend. If you spin up a brand new account, the warehouse that comes with the account has a 10-minute auto suspend. And with Snowflake, you're paying by the minute. So if you run one query and then you have a 10-minute auto suspend, let's say that one query takes 500 milliseconds to run, you're actually paying for the 500 milliseconds plus 10 minutes of idle time. So the number one thing, and I feel like a lot of customers, I just feel like a lot of us feel like everyone knows this already, but then when I actually see it time and time again, it's actually not true that everyone knows this already. So the first thing that you should do is log into your Snowflake account right now, go into your warehouse configuration settings and look at what that timeout is. If it's 5 minutes or 10 minutes, it's because the person that set it up accepted the defaults. And if it's 1 minute, it's actually set correctly. And the reason why we always say 1 minute is because Snowflake does have a 1 minute minimum billing increment. So as long as you are more or less compelled to pay for that 1 minute of time, you might as well have it running in case another query comes along. You might end up double paying. So if you can actually set a smaller timeout, or you can tell a query to suspend right when it's done. Like you can put a SQL statement that says like alter warehouse name suspend. You probably don't want to do that because you can end up double paying. One example I like to give is if you did something in a loop, like a Python loop that said like select one and then warehouse suspend, and you said loop that 1,000 times, it would take less than a second for that Python loop to run, but you would actually pay for 1,000 minutes because each query would turn on the warehouse for a brief moment in time, it would suspend it, and you get that 1 minute minimum billing increment, and then it turns on again, and you hit that 1 minute minimum billing increment every time the warehouse resumes. So they're not actually looking for overlapping minutes; they're looking at warehouse resuming. So that's something to look out for. There is like, don't auto suspend or don't throw that suspend SQL statement. Let it auto suspend in 1 minute. So
Got it.
spend a lot of time on that tip, but it's like as I said, I do see it over and over.
Yeah.
An- Another big one here, just still under the virtual warehouses section, is on consolidating warehouses. So the one mistake that I did myself, and talking with others who specialize in this area, pretty much everyone does it, is naming warehouses like they're cost centers or like they are assigned to specific departments. So you can have like extra small finance, extra small supply chain, extra small HR. That way you know who's like using them. And Snowflake gives you a dashboard where you can very easily see spend by warehouse. So it's almost like they're making it seem like that's the right thing to do and the obvious thing to do. But really, you only want one warehouse per size in most cases. Again, there's no one size fits all advice, but the reason I say to not proliferate your warehouses is because if you can throw more queries at the same warehouse, the chances are that they're going to be sharing that 1 minute minimum billing increment, or that the queries are going to be hitting at the same time while the warehouse is already on. So if you have two warehouses running at the same time, you're paying twice as much. But if you throw two queries at one warehouse, you're going to pay half as much as the other scenario. So warehouse consolidation, one warehouse per size, and also on sizing, the rule of thumb is always start with an extra small. There's a lot of press out there. Big data is dead, and in a lot of cases, that's true. It's not always dead. If you're a big tech company like Uber or Netflix, you have real big data, and an extra small warehouse won't do anything for you. But in a lot of use cases, a company can get away with a single extra small warehouse. So I would say always start with an extra small until a particular workload, a particular query, a particular model, or a particular dashboard grows into the small, the medium, the large, and kind of move on from there. I do need to pick up pace a little bit. I did see a question come in, and we'll save that for the end of this Snowflake section. We will answer your question. I'm going to talk real quick about storage best practices. So Snowflake doesn't charge much for storage. They charge $23 per terabyte, depending on your tier, your negotiated pricing, your AWS region, or your cloud provider region. The price varies a little bit, but on average, what I see customers paying is $23 per terabyte, which is the same as Amazon S3 storage. So they store your data in S3 and they pass the cost through without trying to make a profit off of the storage. But there's a few things you need to watch out for, which is time travel. So every time you update a record, Snowflake will store a copy of that record. So avoid update statements that update an entire table every day or multiple times a day, because every time you update a record, it's storing a copy. So if I update without a where clause, I update 1 million rows. Now Snowflake is storing 2 million rows. It's storing the original and then the updated set. And something called failsafe, which is just the same as time travel, but it's kind of after the time travel expiration period has elapsed. they keep your data for 7 more days on the customer service side. So if you call them with an emergency, they can recover your data for you for 7 additional days. Um, but the one liner here is avoid updating records as part of your ETL process if you can, or at least mass updating without a where clause or without targeted updates. And then the third big point here is just make sure that you understand what's going on with your costs. Understand your cost by warehouse, understand your cost by database, by user group, by query. Come up with ways to assign users into groups and to report the cost by those groups. And again, don't use warehouses as that thing to group by because you're just going to end up paying more. And use Snowflake's built-in features for they have something called a resource monitor, which will either alert you or turn off a warehouse once it reaches a certain threshold. So you definitely want to be using those built-in alerts from Snowflake as well as building your own reporting. Or I recommend procuring a low-cost tool that helps you understand this type of reporting.
Yep, that was awesome, Jeff. I'm not sure about our attendees, but I really learned a lot from that part of the cost section because so many good nuggets right there, especially the one about where you pay for a minute all the time, right? If you just recur 1,000 times, really enjoyed
Yeah.
that. So just shifting a lever, you can say, where like we discussed cost right now. Are there any certain set of performance strategies that one can utilize to maybe a best practice, you can say, in terms of performance optimization?
Yeah, so it's understanding the different data structures that Snowflake has available for us. So we have views, we have tables, we have materialized views, we have dynamic tables, we have external tables, we have iceberg tables, the list goes on and on, right? So all of these things are called projections. I like to just call them rectangles. So data is a rectangle, right? Data is rectangular. And a rectangle is anything that you put in the from clause of a SQL statement. Could be a CTE, it could be a view, it could be a table, etc. So a big part of the performance optimization journey is really thinking through, is it time to turn this view into a table? Is it time to turn this table into an incremental model instead of building it from scratch each time? And really thinking about where your bottlenecks are. And one really good example I can give here is if you're a NetSuite customer, you have this thing called the transactions table, and NetSuite will log every transaction in one table. Sales orders, shipments, financial transactions, you name it, things that are not related, all the transactions get logged in one table. And you might have to join like 40 or 50 tables to get one transaction table that serves all use cases for the business. So you have a DAG that has a single point here and it has a very wide area coming into one point, but then it's one transaction table that everyone else needs. So then it spreads out like this. So it's wide on two sides with a skinny thing in the middle. If that thing is a view, it's going to be really slow because of the number of joins that it has in it. And then all your downstream objects for hundreds of users and dozens of downstream objects, they're all going to be slow because that thing is a view. Turn that thing into a table and alleviate the downstream bottlenecks. So it's it kind of an art of picking table view, dynamic table, materialized view. But it's really putting a lot of thought into that process is what I would say, and just looking for those bottlenecks and where you need your performance optimization.
Awesome, awesome. Uh, so just on the topic, anything else you want to cover, or I have a very
Um,
key question coming up. That's why.
what's that? You have what coming
I
up?
was just saying, if you're done, I have a very greedy question coming up for myself and for.
Oh, yeah. Why don't you ask your question?
Yeah. So I've asked you about cost. I've asked you about performance improvement. Is there any example you can share from your 18 years of experience, right, where you were able to reduce cost and improve performance?
Yeah. So, I mean, let's hit the next slide. So this is a great one here. So this is a screenshot from a Snowflake account that was spending over 160 credits a day. And by consolidating warehouses and by reducing the timeouts, so those two low-hanging fruit, really simple performance tuning mechanisms, or cost savings mechanisms, we were able to save like over 100K a year is really what this slide is saying, just by doing those two simple things. So you can see like in the third stack, the third bar, above the purple, there's like 5 or 6 or 7 different colors that are all kind of blurred together, but they all just go away completely because you just consolidate warehouses. So now you're sending the same queries just to fewer warehouses. So all of that just goes away. And then the big shrink in the green bar was from aggressive query timeout, and pushing more queries, again, more queries to the same warehouse. So that was really fun, a really fun thing that we did that saved a ton of money and took close to zero effort. And then I'll tell more stories later about some other performance optimizations and stuff like that that we've done.
Okay.
Um,
Uh,
we
Like,
do a little bit have to keep an eye on time. We have a lot more to talk about on the Snowflake side, but I think we can kind of skip some of it.
we
Um,
can.
I'll just hit one more bullet point, which is the query acceleration service.
Oh yeah, got it.
And then we'll move on to ingesting data. Okay.
Sounds good.
Um, so Snowflake has this query acceleration service, which you could pick, let's say, an extra small warehouse, and then if it sees a huge workload, it'll actually dynamically increase the size of that warehouse. There's two tips that I want to give there. Is the first tip is beware of the defaults, because the default will allow you to scale up to 8x of your whatever your regular warehouse size. So it would let your extra small scale up to whatever 8x of an extra small is. That's probably a little bit aggressive. So maybe back that off to like 3x or something like that. And another tip about the query acceleration service is there is a view that Snowflake comes with. It's called Query Acceleration Eligible View. And you can query that view to see if the query that you're hoping to optimize is eligible for acceleration. And so check there. So great tip there.
Cool.
In other, like if we had an hour to go into this, I would love to get into like scaling horizontally, scaling vertically, and all of that stuff, but we're gonna just kind of keep it going here. So
Yeah. So next part, I guess, is where I'll be taking over. And again, in the essence of time, I'll try to be fast and efficient like our pipelines here. So
yeah. Cool.
uh,
So I actually have a few questions for you here. So how do you determine when to use ELT versus ETL?
oh, awesome question, because I get this from our customers, you can say on a daily basis or maybe on a weekly basis. And our recommendation to our customers is always that your there are, I would say, three factors which we look at mainly. One is your data volume and your required velocity. Now, if you have like high data volume, like large data sets to move, and you have basically you need high ingestion rates, like your latency requirements are very low, it's always recommended to go for a ELT system, because we'll do your E&L part, and your data warehouses are anyway optimized to do your transformations because they have a lot of computing power and their performance are better because of things Jeff just told. And then if you have a smaller data set and you require lower velocities, it's always better to do a ETL system, because you're only gonna send what is required into your warehouse. So the next part is again similar to this. Your transformation complexities actually define what all you are able to do. So if you have very simple transformations, you don't need to really use an ELT approach. You can go with an ETL approach. But if your transformations are really complex, and that's when tools we'll discuss like DBT come into picture, we recommend our customers to move to something like a ELT approach because it's much more efficient. So the last thing is your data source variety. One thing I feel which people overlook sometimes is that your ETL can happen on one source. You cannot aggregate between sources and do ETL. It's at a source by source level. But when you come to ELT, what happens is you have all your data already present in your data warehouse like Snowflake, and then you can just do your modeling or post-load transformations at the warehouse level, and all the heavy lifting gets done by your warehouse itself. So these would be the three things I would say where You use your these three pillars and decide whether you want to go with ELT or an ETL system.
Makes sense. Hey, could we advance the slide one page just so the folks have something else to look at?
Sorry.
Thank you. Great. And then, so my next, and thank you for that in depth on ELT versus ETL. And I was just, as you were explaining it, thinking that most cases that I've seen that actually do extract transform load end up doing further transformations. So it ends up being EL
TL.
or ETL or yeah, ELTL or
ETLT.
yeah, ETLT. Thank you. I was like, oh my gosh, the nerves are twisting my tongue.
Yeah.
But you see what I'm saying there. So that's also something just to think about. Like, hey, should we just straight ELT it instead of the other?
Yeah. Me as well, Jeff. Entire time I was talking, I was thinking, I hope I'm not mixing up the two concepts.
Yeah, yeah, ETLT.
Yeah.
Okay, so how do we keep our data pipelines cost effective? I think that's what people really want to know about is especially when it comes to loading data. How do we keep it cost effective?
So, uh, to be honest, like you said, there are a lot of simple tactics you can use which get overlooked, and it's always best to do all of them to get your best cost optimization. Few of them is like your ingestion frequency is quite required. Like, let's say you have an ad source, you really don't need data to ingest every 10 minutes because ad sources in general aggregate at a very slower level. So you need to optimize for your ingestion frequency depending on your source. Then the next 2 points are very similar, which is you need to leverage incremental loading or use CDC. You really don't need to full load all your objects. That is, take all the records that are there at source and dump it into destination at every ingestion. You can actually just take a delta and say, this is all I need. Everything else is already there at my destination.
So
And
so change data capture is really performance and cost optimization.
yes, it's beautiful. If I have to
Yeah.
say capture it in one word, because it solves a lot of issues in terms of latency, consistency, cost. So if you are able to do CDC, it's a must do. If someone asks me what is one thing to do to save costs, I will say use CDC. And because it's going to be cost effective at your source and less resource intensive there, and even better at your destination in terms of storage costs and, like you said, the query run costs as well. So it just solves all sides of the problem. And then just skipping through a few of the things like handling your basically you need to make sure your pipelines are running on an off peak hour. Just because your resources aren't too uh, shared and slow everywhere. So that's what we're trying to optimize in terms of non-peak hours, and always monitor your pipeline and auto scale instead of just setting up a large warehouse like Jeff mentioned, right? It's always better to start small and scale as your requirements increase, because that way your costs are always controlled. And then keep monitoring and have alertings in place so that you are aware of your spikes. Basically, a lot of our customers come up and tell us, hey, my bill just shot up out of nowhere and I have no idea why. It's purely because maybe someone in the database team just did a complete update on their table, and now all that's flown through. And because of that, customers are just surprised on why is this happening, because their DBA admin must not have informed them, and the user of the pipeline is completely different. So it's always good to have internal alerting and monitoring in place, so you're always aware of seasonal spikes or even spikes that you are not aware of. So those are just a couple of things to look at.
Yeah, monitoring is important for all aspects, right?
Yeah.
So, like when it comes to real-time data pipelines, what are the challenges that you see companies facing?
So most of it is gonna be very similar to what I've already explained, because cost and performance is mostly where the big picture is. So data latency and consistency issues, a lot of time, like we hear our customers say that I had a latency requirement of 15 minutes to my customers, but it took 30 minutes for data to reach. So you really need reliable and pipelines that can scale. So again, that's where Hevo comes into picture. Another very common issue is schema evolution. Like customers always keep, like, your database are not static or your source is not static. It is always going to have new objects, new fields coming in. And sometimes what happens is your system is not able to automatically detect these changes and evolve. And that's also something we at Hevo make sure that we are having an automatic system where our schema evolves. And also we give a customizable solution for our customers to control on whether you want a new table to be added automatically or just ignore it automatically. So a lot of control is what customers look for. And one of the again, monitoring and debugging. A lot of our customers ask for multiple types of logs, like activity logs, just so that they know what's happening at the pipeline level. There's another type of log called audit logs, where they want to know with each run of their pipeline how many events were processed, how many records were failed, successful, at what time did load complete. So these are just couple of logs and monitoring services our customers like our P0 for our customers. And then I would say the other thing is integration with downstream systems because you need an architecture that scales and also an architecture that is able to work cost effectively. Like I'll just piggyback on something you mentioned on if you run updates on Snowflake, it's not always going to work. So sometimes there are customers who come and tell me, just append my data. Don't update, don't merge, don't do any update queries on my Snowflake, just keep appending data so that I don't incur costs. So you need a solution that's flexible to even merge if required and also be able to append and save costs for you. So again, we can talk about this for days because every customer I talk to has a different challenge, but these are the high level modules that I wanted to cover.
That's awesome.
Yeah. So
Any questions from the audience? Go ahead and type it in the chat. I think we're just going to do all the questions at the end instead of at the end of each section. So, David McCandless, thanks for your question. I typed, I will answer this at the end, and then it marked the question as answered, but I will remember to come back to it at the end.
yeah, sorry. My bad.
It's okay. So, yeah, now we're going to move on to talking about my favorite thing, scalable data transformations with DBT. So let's dive in here.
Yeah. Uh, I'm going to ask you the same question you mentioned. Like, what really is a scalable data transformation on DBT? Like, I'm very curious to learn. I've heard of this. I've not worked on this, but I want to learn.
Yeah. So when it comes to scaling DBT projects, it's more than just about scaling performance. Okay. It's about can your project scale to support rapid requests from the business as your data engineering team grows or your analytics engineering team grows? Can you maintain those processes and that quality? And can you maintain speed? So these are some things that I think about scaling that are outside of performance. So let's just go ahead and talk about all of it. When it comes to the non-performance scaling, is your project really well structured and well organized? So a very common thing to do is to have folder structures in DBT that correspond to schema names in the database. And you might be organizing your like bronze, silver, gold layers according to these folders in your DBT project that end up that way in your database, or sometimes staging, intermediate, and marts. But you really want to think through how your project is organized, this schema naming macro, and how the schema names get generated in the database. If you're going to be splitting your project across multiple databases, how that works, which can actually get complicated, but I see it done frequently. So overall organization of a DBT project should be really well thought out and enforced. The next one is just like test coverage. It's not too much to ask to have 100% test coverage. Especially, I know this is more about Snowflake, but like Redshift will let you create an invalid view and there's no error message until you try and select from the view. So if you use Redshift, having a test on every view is actually really important because otherwise no one might ever select from that view and you wouldn't know that something was wrong. So the test will select from that view and will fail right away. Snowflake, I think, like we don't have that same problem in Snowflake, but have really good test coverage on all your models. A thorough code review process, pull request or merge request process, depending on your Git provider. really senior people who understand the entire project, reviewing the project, robust CI/CD pipelines, like the person reviewing the change request should know right away that hey, this ran in our CI environment and all of the tests passed. The model's built successfully, the tests pass. All of the changed models plus the downstream objects of those changed models, all of those tests will run in CI and pass. So that's really important kind of for scaling your project and keeping it trustworthy and organized. And again, appropriate materializations like what I talked earlier about when to use a table, when to use a view. And again, it comes down to really thinking through these things. Now, there's some generalizations that we can make and that DBT Labs makes in their style guide, like staging layers should generally be views, and things that have exposure to end users should generally be tables. And I think generally that's a place to start, but not every end user object needs to be a table. Sometimes they can be a view if like all you're doing is adding one column that's a calculated field. But it's understanding the thought process for thinking through these things.
Awesome.
Um, I
Yeah.
do. Let me just give me one sec here. Yeah.
Yeah.
So why don't we go on to the next question?
Yeah, totally. So, just in terms of the good practices, right? Now, I want to try to understand a bit more about scale, right? Like, what would be certain things to keep in mind when I'm writing a scalable DBT model, right? What is a
Yeah.
scalable DBT model? Yeah.
Yeah. So, again, it's going to come back down to that materialization type, whether it's a table, a view, or an incremental. So I think when tables become slow, adding in incremental models is critical. And a lot of DBT developers kind of know this already. But one trick that I think really, really helps is dynamically scaling your Snowflake warehouse on a per model basis. So your default warehouse in profiles.yaml for the entire project is an extra small. And
Uh-huh.
on these models that tend to cause you a bottleneck, you can config a different warehouse for that one model. So like, hey, everything runs on an extra small except for this model runs on a 2XL. And that's a really great way to get better throughput on your data pipeline without needing to actually change SQL.
Mm.
And then we won't have time today to actually talk about tuning the SQL, but this is something that data engineers love to get into is understanding micro partitions in Snowflake and how Snowflake can basically drop micro partitions from the scan process, which is called query pruning. But that is critical to kind of understand and making sure that you're configuring your DBT models to enable Snowflake to do query pruning. So that would be setting your cluster keys in the different models.
Okay.
Yeah, that's basically my best advice on that question.
Uh, awesome. So, I heard you touch upon incremental models, right? So, how should teams approach incremental models in DBT? Like, what is the
Yeah.
balance of performance, complexity? Like,
Yeah. So incremental models can be a little bit more complex, especially if you don't know what you're doing. And as much as I absolutely love DBT and democratization of data and like kind of giving access to everyone to be able to write SQL, what we have with DBT is like I would say one of the only downsides of DBT is that we have a bunch of people who are building models who have never done transformations the hard way. So they've never written the insert, update, and delete statements. They've never written the create table statements. They've only written the select statements that DBT allows you to write. So my best piece of advice here for the complexity of incremental models is to look at the verbose logs, the detailed logs, to see what it's actually doing and how the primary key impacts about how things will get deleted and reinserted or merged into, et cetera, and really understand the interworkings of what this incremental model is doing before just doing it, right? Maybe that's not for everyone, and I don't know. Maybe DBT would say the opposite and say, no, the whole point is that they shouldn't have to know how this works. But I've seen time and time again where people forget to put like a primary key in their incremental model, and it just every time it runs, it just reinserts all the data again. And then they have a post hook that like deletes the duplicate data and like all this crazy stuff. So I would just say, backing up a little bit, start with views, move on to tables when you need to, and when tables, need that performance optimization, move on to incremental models. And when you do move on to incremental models, spend a day or two really just understanding it.
Got it. So just to clarify for everyone, when you talk about the logs, you mean the runtime logs within DBT itself, right? The console
Yeah,
log.
so when you say dbt build in your CLI, it's giving you just like standard output logs, which are not verbose. But
Yeah.
then if you go, there's a folder called logs, and in there there's a log file, and that's giving you every SQL statement that dbt ran under the hood, every insert, update, delete, merge, create, etc. That's where you find that. It's a little bit hidden from you. If you use dbt cloud, you can click over to it pretty easily and read those logs there.
Within your run history itself, you'll get all of them. Yeah.
Yep, exactly.
Got it. Awesome. So another thing is, do you want to share some example of a DBT implementation that like significantly improved transformation speed or like data quality, right? Is like,
Yeah. So it's so hard just to pick one example because like my career has just been like example after like this is what I do all day, every day for the last many, many years. But one that really shines out is a project that I worked on with Harvard Business Publishing, where we had an Alteryx based process for their one of their data marts. I'll just be very vague. And this Alteryx based process had a few flaws, which is that not it wasn't understood by a lot of people other than like two or three people. And it was very slow. It took like 35 minutes to run. All
wow.
of that time running on Snowflake, with so like 35 minutes of Snowflake spend and 35 minutes of resources being consumed on Alteryx server. Transformed the whole thing to dbt, documented it extremely clearly using the markdown. So people would go through and they would see like beautiful markdown for every single model in the DAG. Anyone who put any effort into understanding it can now understand it. And the performance went from 35 minutes to under 2 minutes to run the entire thing.
Oh, wow.
So that was really fun. And the trick that we did there was one model that was the bottleneck, and that model got a bigger warehouse. Everything got an extra small, but one model got it was a 2XL. So that was
And like,
just incredible.
like boom, like a 15x improvement is what you saw there.
Yeah,
This
yeah. So that's a fun, quick example without going into any confidentiality details. So
fair enough. So
let's skip over the Jinja part because we are gonna face a time constraint here. So
we will. So I think in the interest of time, let's move on to our next interesting topic, which is performance tuning in Tableau. So
yeah.
I'll again quickly dive into it. Now, what would you say are certain best practices you need to do in Tableau? And if you can just cover all of the
Yeah.
practices there.
There's some conventional wisdom that says that you should use extracts instead of live connections to Snowflake. And this conventional wisdom maybe should be looked at a little bit more carefully.
Okay.
So, yes, if you always extract your data when the users are dragging and dropping in Tableau or they're consuming dashboards and throwing filters, an extract is great for cost savings because it's not hitting your warehouse with every click that a user does in Tableau. However, you have to think about, is this dashboard going to be used a lot? And is the usage on this dashboard going to outweigh the amount of time that it took to create the extract? So
Okay.
if you are requiring hourly refreshes of your data pipeline as well as your Tableau data set, so we know that this data set is running at least once an hour. Therefore, your Tableau data extract is running once an hour. Let's say it takes 7 minutes to refresh that Tableau extract.
Okay.
Are people going to use it for more than 7 minutes to gain that cost benefit analysis
Oh,
in that 1 hour window? And if it's once a day, Hopefully they're using it for more than 7 minutes in a day, but maybe they're not.
Yeah.
So sometimes it's easier to maintain a live connection, and sometimes it might save you money. So understanding the usage of your dashboards, I call it BI on BI. So it's like business intelligence that tells you who's using your dashboard and how much they're using it, could
Yeah.
help you make that decision of extract versus live connection. But certainly on a dashboard that's heavily used, that the business relies on, and if you have like over 5 users on a dashboard
Yeah.
that use it every day, probably an extract is going to be a good thing as long as the data set is not in like the hundreds of millions of rows. Once you get like past like let's say 20 million rows, you can't really use an extract anymore because Tableau will time out or the extract will actually be slower than using a decently sized warehouse in Snowflake.
Awesome. Awesome. So, just was thinking about something, which is when people are trying to optimize Tableau dashboards, right? Like, what would be some mistakes they make, and are there any features out there on Snowflake or something else that would help you to improve your Tableau performance or troubleshoot them even?
Yeah. So mistakes is just too many objects on a dashboard. So every chart is a SQL query, every filter is a SQL query. Like, so every time, like if you just have filters across the top, each one of those filters needs a select distinct thing from table to populate that drop down menu. And of
Yeah.
course, every chart is a SQL query. So if you have 15 filters at the top and you have like 15 charts on your dashboard, that's 30 SQL queries that are going to get sent to the database all at once. So reduce the number of filters, reduce the number of visualizations. That's the number one mistake and like low hanging fruit, like piece of advice.
Mhm.
As far as advanced Snowflake features, yeah,
Yeah.
there's one thing that I love doing here, which is if a business user comes to me and says, "Hey Jeff, I got a slow dashboard." And
Yeah.
we say, "Okay, let me take a look." I load the dashboard, and while that dashboard is loading, I have the Snowflake query history window open. And so this dashboard is going to throw 30 queries at Snowflake all at once. I can find one out of 30 queries that's slow. And then I go into that query and I look at the query profile plan and I can
Okay.
find the node of that query that's slow. And it always comes down to usually a level of detail calculation that's hanging the thing up. And then I
Oh,
can go back to the business user and say, which which calculation is spreading the dates across all time or something like which calculation is doing this type of like spreading. And then they
okay.
could say, oh, it's this one. I'll say, just delete that calculation, load the dashboard again. They delete the calculation, boom, the dashboard comes right up. And we say, okay, we found the problem.
Awesome.
So like, all right, let's fix this. Let's either pull that back to the database instead of doing it in Tableau if we can, or let's figure out another way to calculate that field. That's going to be faster. So
Awesome, awesome. That's some groovy query optimization and all mixed there. That's sounds
yeah.
interesting. So I think I'll move to the last part where I think we all would like to hear like a you can say a case study where
Hmm.
all of this was like applied at a real life scenario, right? Where you were
Yeah.
an organization for this. So maybe that'll just tie it up beautifully for the webinar.
Yeah, so about a year back, I was consulting for a medical devices manufacturing company. When I came in there, I observed a few things. There were thousands of DBT models, and many of them were not used by exposures, so by business users. Many of them just ended kind of in the intermediate layer. Um, I noticed that the business wasn't trusting the data. I noticed that the spend was out of control. So I saw like a bunch of symptoms. So we just kind of went through systematically, like and said, here's how we solve this problem is like, let's figure out the handful of dashboards that are really critical for the business. And let's trace that chain backwards and say, these are the most important things and then basically start over with a clean slate and say, we are going to build a fresh project that supports these handful of things, like between 5 and 10 things. And make sure that's extremely well tested all the way throughout. The change control process is in place. So it's a very kind of, I have to be careful about client confidentiality here. So it's a very vague case study. But if you can get a sense of my processes, like starting with, hey, what does the business really rely on? And what is that thing that they don't trust today that's really important for them to trust?
Got
And
it.
those are the things we're going to start over. We're going to rebuild according to all of these best practices, which we just said.
Got it. Uh, awesome. So now with that, I just want to again bring this webinar narrower and narrower. If you have to give out one takeaway from today's discussion that every data team should follow or remember, like what would be that one key nugget from Jeff that they should take away?
Was that a question for chat or a question for
No, no,
me?
it's for you, Jeff. It's
It's
what
a
would
question
be
for
your
me.
way yeah,
Okay. I'm sorry. So, what I would say the one key takeaway is just make sure you're monitoring, make sure you understand your costs. And this can actually help me segue back into David McCandless's question from the chat. He was asking if you're wanting to attribute costs to department and have a single warehouse, so they're not doing warehouses by department. And let's say you don't want to pay for a tool. What's a good way to track those costs, like query tags, et cetera? So yes, query tagging is great. You can put query tags in your DBT models. You can also just put tags as query comments in your DBT models. So you can actually put a JSON structure in a comment that you can then query for that JSON structure. Uh, but then you have to think about, okay, what about Tableau, et cetera? So what I could just answer very generically is you want to come up with a system using the Snowflake query history views that they give you to
Okay.
be able to do this by user, by role, by database are like three things that really come to mind of like better ways than using warehouse to allocate costs is allocating by roles and by the database that was queried. And
Nice.
then and then tying that back to your question is what's the one takeaway from this is make sure that you're monitoring and you're understanding where the spend is going and where the performance bottlenecks are. And
Yep.
if you're measuring it and you're monitoring it and you're understanding it, that is 85% of the battle.
Awesome. Awesome. I think that's all what I had today. I think we can open up the floor for any questions the audience has, and I can already see few coming in.
Yeah, I'd be excited to answer more questions.
So I think you already covered David's first question, right?
Yep, yep.
I see there's one more question, which is what is the most effective strategy for assigning a Snowflake warehouse to run 100 interdependent DBT models daily? Should all models use same warehouse relying on DBT to manage execution until completion, or should different warehouses be assigned based on the data volume each model processes?
Yeah, it's kind of both. So you want one DBT warehouse to build those 100 models. If those 100 models are all views, it doesn't DBT and Snowflake will work together to figure it out. So one thing that I can tell you is increase the number of threads. So the default I think is 4, but you can bump that up to like 16 or like even 24 threads, which means that Snowflake will try and build 24 views at the same time. And guess what? It does a pretty good job at it. Um, if you overwhelm Snowflake for a certain period of time, it can scale up or scale out, I should say, another warehouse. So if you have your auto scaling configured that it can spin up extra warehouses, it will go from one extra small to two extra smalls to three, et cetera, as needed if you overwhelm it for minutes at a time. And then it'll chew through that workload faster. But especially for creating views, it does it so incredibly fast that 100 models is almost like nothing if they're all views. The project will run in 30 seconds or less. And then once you're finding those bottlenecks on the tables, when you find individual tables that need more horsepower, before just giving it more horsepower, giving it a bigger warehouse, see if you could figure out, look at that query profile, see what's going on with it, see if you could actually fix the problem But if the SQL is already optimized, then you have to give it a bigger warehouse and you do it just for that one model. There's another one coming here. Feel free to follow up on that question too. So it says, for any similar future session events, would it be possible to do a demo of cost saving tips, optimization techniques of a SQL query and Snowflake? Yeah, so we didn't get into actually SQL tuning, but we could potentially do a webinar just on that one topic. So we had covered like four gigantic topics today, right? Snowflake, Hevo, DBT, Tableau, so in 45 to 50 minutes. So, of course, no time for details, but um, good suggestion. Thank you.
Yep. Anything else? I
Give me another question.
Yeah, let's see.
Come on, peoples.
Test Jeff's 18 years of experience, guys.
Let me
Mhm.
see.
Keep it open for a minute or so.
Are we able to see those poll results? Because I'm actually curious. There's a few polls that popped up that on my side, I'm not actually able to see the results. Have you found that? Oh, polls and quizzes.
Looks like we have a question from Kevin here, Jeff, which is, will you tell us more about Query Accelerator service in Snowflake?
Um, there's not too much I can tell you in a very short amount of time, other than log into Snowflake, go into the admin section, click warehouses, click create new warehouse, and then click like more options or like advanced options or something like that, a little drop down that will expand that window. That's where you're going to find the query acceleration service settings. And the query acceleration service, basically what it does is it'll make your extra small warehouse faster, right? It'll accelerate that warehouse. But again, be careful of that default of, I do think it's 8x is the default, which could probably be very expensive. So you want to play with it, but that's where you find the setting. I I don't really have much time to like kind of demo or anything like that, but hopefully that helps. Um, I heard sometimes it's problematic and or expensive. Yeah, so you do want to query that view called, I think it's called query acceleration eligible view. I have the exact name in the notes here. And that query, if your query is eligible, it will help and it would actually could be cost neutral for using it. But if you're using it and the queries aren't eligible, you might be spending some unnecessary money. And also for the person you heard from that it was expensive, I wonder if they like let it scale 8x because that's the default that Snowflake gives you, because 8x I'm sure is expensive. Um,
And I think there's one more there, which is how can data modelers be more involved in any DBT related activities at work? I notice more data engineers use DBT a lot, and how can data modelers contribute to data engineers' work? It's from Krishna.
so I think this question speaks to kind of the crossover in roles between data engineering and analytics engineering. And to me, it's could be all be one role if you want it to be. Like when I was starting out, there only was one role, and it was called business intelligence developer. Like a BI developer did it all. They did the pipeline side, they did the dashboard side, they had to work with the business. Um, of course, as time went on, this broke up into smaller and more refined roles, which suit different aspects of it. But the question is saying how can data modelers be more involved in DBT related activities? Um, I don't really know how to answer that other than if you're looking to do more crossover, just start doing it. Like ask your manager, or do what I do, which is don't ask, just start doing it, start learning things. Um, It's a tough question without being able to have a conversation with you on more of the spirit of it. So I do apologize for not giving a great answer there.
Oh,
Arjun, did you have a different understanding of that question?
no, I think you've answered it from what even I understood.
Okay.
It, but
There's one
let,
more question came in, and then this will be the last one because we're right at the edge of the hour here. Let me just give it a second to read it. Okay, so from your case study, you mentioned that you talked to the business and found out what dashboards matter and created new models and used old DBT models and improved them. The problem is gathering information when there are thousands of assets and how to go about. Yeah, so in this case, I had to lean on people who had been there for a long time. The data leader was very well networked with the executive suite, and he knew exactly what the executive pain points were before I got there, and he knew exactly which dashboards weren't trusted that were like heavily used and not trusted. So he brought me in to solve a very specific problem that he already had an idea of what was going on. And so in my case, it was basically like he was just like, here's the 5 to 10 things that we need. Let's like go do it. But if you're a data leader, um, this is going to be your role is constantly networking with the business and treating them as your most valuable customer, like having that startup mentality where if you've ever used startup software, they love feedback. And like you could be like, what would be really cool is this one little feature request. And like the next day that feature request is there and you feel so valued as a customer. That's what you want your executive leadership team to feel like if you're a data leader. You want them to feel like, oh wow, like my little feature request was really valued and boom, it's like right there, right away. So having these constant conversations with them, understanding your business leaders, and then having that drive your entire workload. So I think we're gonna wrap it here. So we're like right on time. I want to thank everyone for attending. Arjun, thanks for being a great co-host. It's like really, really awesome. Great webinar.
thank you so much, Jeff, for coming and sharing your expertise with us. Thank you, everyone, for attending our webinar as well. We'll be sharing across some more additional details through the email to the emails that you have registered with, where you'll be able to get links for signing up for a technical consultation with Jeff, and even hands-on resources and a free trial access link for Hevo as well. So stay tuned for that as well in your emails. Yep. Thanks, everyone. Thanks.